नमस्ते सर, मेरा नाम अभिषेक है और मैं आपका सर बहुत धन्यवाद करता हूँ। आपके जो यूट्यूब पे वीडियोस हैं उसके थ्रू मेरे को काफ़ी सपोर्ट मिला मेरे डिजिटल सिग्नल प्रोसेसिंग सब्जेक्ट में, और आपकी वीडियोस के थ्रू मेरे जो कंसेप्ट है वो क्लियर हो पाए और काफ़ी सपोर्ट मिला। तो सर उसके लिए धन्यवाद करता हूँ, क्योंकि अभी हाल ही में मेरा रिज़ल्ट आया और मैंने काफ़ी अच्छे मार्क्स के साथ जो है अपने सेमेस्टर को क्लियर किया। उसके लिए आपके सपोर्ट के लिए, आपकी वीडियोस के लिए सर बहुत धन्यवाद करता हूँ। और जो आप काम कर रहे हैं उसके लिए बेस्ट ऑफ लक। और जो है मैं रेकमेंड करता हूँ बाकी जो लोग हैं कि आप सर का वीडियो देखें और अपने जो डाउट्स हैं उनको क्लियर करें। थैंक यू।
Hello everyone, welcome to Naresh Joshi channel. So please subscribe our channel. It's humble request to all of you. Subscribe our channel and share this video to maximum your friend and your all in your family members, those who are going for the engineering, okay, and also other any electronic science subject, okay. So this topic is very useful, and this topic is we have taken previously one numerical, okay, and today I am taking the another numerical. So because I realized that it's required two numerical, so which is clear your all concepts, okay. So if you like this video, please share it, okay, and one more thing, subscribe our channel. It's humble request because I need your support to reach 1 lakh subscriber, okay. So now you can see what is the problem we are taking here. So find Vx for the given circuit diagram using the superposition theorem, okay. So this question are the one of the standard question which I have taken here, okay. It can be asked in the university, similar type of question, not same question. It can be, okay, you find this question, such type of question in many competitive exam, university exam, all everywhere you will see, okay. So let's see what how can we solve it, okay. So here you can see that there are two sources are given. One is the 20 volt and another is a 10 ampere. That means voltage source is also given, current source, and one dependent sources. So remember this dependent sources. How can we solve this question? So you will watch this video till end. So you will understand how can we apply the concept and how we can solve this. Remember this, we will not consider dependent source because dependent sources is the depend on this voltage source. This is the current source, but it depends on the voltage source. That's why its value is Vx by 2. Okay, only we have the two sources, that is the 20 volt and 10. That means we need to follow only three steps, okay. So this one step for the 20 volt, second step for the 10 ampere, and third step for the superposition theorem, okay. So let's see how can we solve it. So first you can see this diagram. So I consider first step when 20 volt is acting, when 20 volt is acting alone, okay. It is acting alone means what? That means 20 volt is in on conditions, okay, and 10 ampere is in off condition. Off means what? Here it is the current source, so it can be replaced by the open circuit. So OC means what? Here open circuit, okay. So you replace this 10 ampere by the open circuit. So you can see in another diagram here, to save our time, so I have already drawn this circuit diagram here. So you can see this is a 10 ampere. So here we are considering this 20 volt is working only, it is acting, and this is the 10 ampere. This is the we have considered it is off, that means it is open circuited, so we make it open connection here, okay. So now you can see this is our circuit diagram. Now here we will consider this is the Vx dash, okay, and there will be the again Vx dash. Here this is our first step. So for first step, when one source is working, so we will consider dash here, okay, single dash. Now I will modify the circuit diagram. Then you can see this is the again Vx dash and this is the Vx dash, because we need to find out the voltage across the 6 ohm, okay. So this is our motto. So here you can see this is the 6 ohm. Now next you can see after this simplifying the circuit diagram, then you have to follow the mesh analysis, okay. So here you can see that there are two meshes. So this is the mesh 1 and this is the mesh 2. So in the mesh 1 I will assume that is the current I1, and in mesh 2 I will assume current I2, okay. How we can solve the question which is using the mesh analysis? So you can see my previous video, you will get all kind of the concept, okay. So let's see. So this is the I1 and this is the I2. Okay, so here there are two meshes. One more important thing, you can see this is the current source, or it is the dependent current source. Okay, and here you will find that this I2 is passing this I2 and this that is the this current source have the same value. Why it is? Because both this is the current source is present outside the branch. When the any current source is present in the outside branch, so that current source, that value of that current source will be obtained directly. You have to remember this golden rule. Again I am repeating here, whenever any current source are present in outside branch, okay, that current source can be obtained directly. So okay, so this is the our second. I think you get you have understood, you got it. Now what you have to next, so how can we solve it? Let's see. So here first step, first what we'll write from the circuit diagram. Okay, from the circuit diagram. So circuit diagram, what we can obtain, so first we have to note down this. So in the circuit diagram I show you here, you can see first thing we have to find out Vx dash. Vx dash equals to what? Here you can see this is a plus and this is a minus. So we have to write down this Vx with respect to I1. Okay, so I1 is coming from in this direction. You can see here, this I1 is coming and here is, so here first sign is plus. So what I will write here? I will write here like this, Vx equals to 6 I1 minus I2. Okay, because that's why I am writing I1 is first here and this is the way. Okay, so because I1 is coming from this direction. Okay, so you can see here, so that's why I have written 6 I1 minus I2. That's why I1 is come first over here. If you write the I2, then I2 will come here, but then polarity also will be changed because this is the negative polarity when I2 will come first. So here polarity also will be changed. It's become negative. Clear? So this is the, you can see what is I, how can you write it? So this is the very important, many students will do mistake here. So always remember, when your current source is moving like this, so what is the sign here? That sign you have to consider here and you have to write this current first. Okay, I1 minus I2. But if you writing this way, so you can see this is the I2 minus I1 and here this is the first sign is what? Minus. So here we will write the minus. Clear? I hope you understand this. How can you write? So from the circuit diagram I will write directly it is. Second thing we can get directly, that is the I2 equals to, you can see here another thing, I2 equals to Vx dash upon 2. Okay, these two things we are getting from the directly, you can see. So that thing I will write here. So first from the circuit we have obtained, that is the Vx dash equals to 6 I1 minus I2. Okay, this is the our, and it is due to the, you can see the due to the conditions, that is the I1. Okay, I have considered the direction for your understanding. I have written this is due to the I1. This is not need to write in your exam, but on this is only for your understanding. Second thing we are getting from the circuit diagram, that is the I2 and this is the Vx by 2. Okay, and what is the value of Vx by 2? You can see. Okay, so this is we can consider this is the equation number 1. So if you put this equation number 1 here, Vx by 2, then you can write, see, 6 I1 minus I2 upon 2. Okay, and this is what? 3 in bracket I1 minus I2. And finally you can see this is I2 3 I1 minus 3 I2. Further you can simplify it. So what we have to do, we will shift this this I2 on the right hand side. Okay, so if I will shift this I2, or you can also do one thing, you can shift this I 3 minus 3 I2 on the left hand side. Okay, so I will shift this on the left hand side. So what is the here 3 I2 plus 3 3 I2 plus I2 then equals to 3 I1. Okay, and I will also shift this I1 on left hand side. Okay, so it's become minus 3 I1 plus, and it is what? 4 I2. Okay, you can shift anywhere, but to keep it as a similarity, because in previous question I have considered I have shifted all the value on the left hand side. Okay, so this is the equation number 2. Clear? You can see this is the our equation number 2 and this is our equation number first. Clear? Always whenever you require, you have to put the equation number. So this is the equation number 2. Now what you have to do next, you can see here in this diagram. So this part is already solved because we have considered this current source. Okay, this current source is present, so we have obtained the value directly this using this equation. So this mesh is already solved. Now only one mesh is remaining, and that is this one. So we need to apply the KVL to this mesh. Okay, so we will write next step, apply KVL to mesh 1. Okay, so this is mesh 1, and what we will get, you can see. So here I will write first how many you can see how many meshes are there and two currents. So I will write directly I1 and I2. So I1 and I2. This is our direct method. And next, what you have to focus. So here, which mesh we are applying to the KVL? So mesh 1. So we will consider this I1 will be negative and remaining all will be positive. Okay, remaining all current will be positive. So this is the way. Then you have to write down the magnitude of I1 and I2. So how can we write down the magnitude of I1 and I2? So for this, you can see through which resistance this I1 is passing. So I1 is passing through 2 ohm and 6 ohm. So this 2 plus 6, this is the 8 ohm. So you can write down here 8 here. Then next you have to write down through which resistance I2 is passing. So through which resistance I2 is passing, which is in the mesh 1. Okay, so you have to consider, remember this. So I2 is passing through the resistance which is common for mesh 1 also. Okay, so this is only the 6 ohm. Not you not need to consider this is for 4 ohm, because it is the not common for the mesh 1. Okay, it is the common for the mesh 1. So I2 is passing through the only 6 ohm. So I will write here 6. And here, what will the magnitude? So for the magnitude, we have to follow this same current, and we are moving in this direction. So what is the first sign here? Negative sign. So and what is the value of the voltage here? 20. So I will write minus 20. Okay, whatever sign is present over there, so that I will write down directly. So this is minus 20. Okay, and this is our equation number, we can say the 3. Okay, so now what you have to do next? Solving this equation. Solving equations 2 and 3, so we get, what we will get when we solve it? You can solve it, it is very simple. So by putting in your calci, you can solve it. I have already solved it. So this is what I1 equals to 5.714 ampere, and second I2 equals to 4.2857 ampere. So I show you how can solve it. So this is the first, you have to go on the equations and select one. There are only two unknowns. So what is the first value of the unknown? First unknown minus 3. So you have to put here minus 3. Then next 4. So enter 4 here. So 4. Next is what? 0. So you have to enter 0 here. Next is what? Minus 8. So you have to enter minus 8 here. Then next is what? 6. So you have to enter minus 6. Plus 6. And then next minus 20. So you have to enter minus 20. And then you have to check it. What is the answer? This is the first I1. So you can see this is the I1 equals to 5.714, and second answer you can see this is 4.2857. Okay, so I have already calculated this previously, so that I have directly written here. Now what you have to find out? Vx dash. Okay, so Vx dash is what? Vx dash from equation 1. So this is the equation 1. So 6 is 6 I1 minus I2. So this is from our equation 1. Clear? So let's see what is this. This is 6. What is the value of I1? I1 equals to 5.714 minus 4.285. Okay, so when we simplify it, so you can see here we can simplify it. So 6 into in bracket 5.714 minus 4.285. So you can see this is the, what is the value of this one? This is 8.57. Okay, so what is the voltage here? Vx dash. So we obtain the value of the Vx dash. So that is, you can see it is the 8.574. Okay, and this is the voltage. Clear? And this voltage is across the 6 ohm. Clear? In when only the 20 volt is acting. Okay, so this voltage is what? Vx dash is what? When 20 volt is acting alone only. And this voltage across the 6 ohm. So this is the first step. Now we can move on our second step. Okay, so in the second step you can see. So second step is what here? So second step, that means when 10 ampere is acting alone. 10 ampere is acting alone. Clear? So 10 ampere acting alone means what? Here you can see that means 10 ampere is on conditions and 20 volt it is in the off conditions. Clear? So 20 volt off means what? It will be the short circuited, because it is the voltage source. So remember always voltage circuit will be short circuited and current source will be always open circuited. So here you can see what we have done. Here we have considered this is the short circuit. Here voltage source put on, so it has been short circuited over here. You can see clear. So now next we can write, this is the, we have to find out the Vx dash. So here we will consider Vx double dash, and it will be also Vx double dash, clear, because we have considered when 10 ampere is acting alone, clear. So next then apply, you have to mesh analysis. Okay, so how many meshes are there? So first you have to write down mesh 1. This is the mesh 1, you can identify the mesh. Then this is the mesh 3. Okay, so mesh 1, mesh 2 and mesh 3, clear. And then you have to assign the currents directions with clockwise directions. So you can see this is the I1, this is the I2, okay, and this is the I3, clear. So here again we have to also write from the circuit diagram which can directly obtain. So from the circuit diagram, always remember first step your will be the, when you are solving the such type of questions, so you have to always write from the circuit diagram, because some of the parameter you will get, you will obtain directly. So here you can see this 3 ampere and this 10 ampere we can obtain directly. What is the, so you can see the direction of I3, this is like this, and this 10 ampere is moving in this direction. So here you can see this both are in opposite direction, so that's I will write here I3 equals to, it is minus 10 ampere. Okay, if direction will be same, so I will write here positive, but it is the opposite direction, so that's why I have written here I minus 10 ampere. Okay, and this is the value of the I3. Okay, so this is the value of the I3. Okay, so next we can write down here Vx dash. What is the Vx double dash? So Vx double dash equals to, again we will consider I1 as a base. I explained you already. So here you can see 6 I1 minus I2. Okay, clear. So this is 6 I1 minus I2, and again we will consider this is the equation number, previous one we have considered the equation number 3, then we can consider this is the equation number 4. Okay, so this is the equation number 4, you can see here that we have considered. Next you can say this is again dependent current source, so we can obtain this current source. So I2 will be here. What is the I2? I2 is equals to Vx double dash upon 2. Okay, so this is the I2. Now what we have to do, we have to put this value of this Vx from equation 4 in this. Okay, so you will obtain I2 equals to Vx equals to 6 I1 minus I2 upon 2. So again it is what, 3. So you can see here this is the 3 and I1 minus I2. So this is what, 3 I1 minus 3 I2. So further you can simplify it. This is the I2. So we will shift this 3 I2 on left hand side, so it's become 3 I2 plus, clear, and it is plus I2 then minus 3 I1, and it is equals to 0. So here you can see this is become 3 I1 plus 4 I2, and it is equals to 0. Okay, so this is the another equation, so we can here mention, that is the equation number, you can see minus 3 I1 plus 4 I2. Okay, so equation number 5, clear. This is the equation number 5. Now you can see only the when one mesh is remaining, so here we need to apply the KVL, clear. So you can see this this mesh current is obtained, so I3, and this mesh current is obtained, that is I2. This equation we have obtained for I2, and another only the one mesh is remaining, so for that we need to apply the KVL. So I will write here, so here apply KVL to mesh 1. Okay, so I am applying the mesh 1, KVL applied to the mesh 1. So let's see what here. So here we will directly write down I1, I2 and I3. Okay, so because there are 3 currents, I1, I2 and I3. Okay, and we are applying the KVL to the mesh 1, so that's I will write here, this will be the minus and remaining all with the positive. Okay, so here then what you do, you have to write down the magnitude of I1, I2 and I3. So how can we write down the magnitude of I1? So we need to check in the mesh 1 through which resistance I1 is passing. So this is the mesh 1, and I1 is passing through the 2 ohm and 6 ohm. So there are only 2 resistance through which mesh 1 through which I1 is passing. So this is what, 2 plus 6, this is the 8. Then through which resistance in the mesh 1 the current I2 is passing. So this is only the 6 ohm. So I will write here, this is the 6. And through which resistance I3 is passing in mesh 1. Only you have to need to check in the mesh 1. This is the mesh 1. and I3 is passing 2 ohm. This is the so I will write here only the 2 ohm, because you can see the 2 ohm is common for the mesh 1 and mesh 2. So only we need to take, because we are applying KVL to the mesh 1, so here only we have to check through which resistance, okay, through which resistance which is present in the mesh 1, so current is passing, I3 is passing. So here you can see the I3 is passing only the 2 ohm, and this resistance is present also in the mesh 1. And then we have to write the voltage. There is no voltage source, so we will write here 0. Okay, so this is our another equation, and here you can see we already know the value of the 10 amp I3, so we will put this value I3 here. So you can see this is the 8 I1 plus 6 I2 and plus 2, and I3 equals to minus 10, and then it is equals to 0. So it is minus 8 I1 plus 6 I2, so it is minus 20 and equals to 0. We will shift this 20 on the right hand side, so it is minus 8 I1 and plus 6 I2, and it is 20. Okay, so now you can see this is our equation number 6. Okay, this is our equation number 6. So now what we have to do here, then we have to follow by solving equation only 5 and 6. Okay, 5 and 6, because we need to find out only I1 and I2. So I already show you how you can put the value on in calci, and you can solve it. So I will already solve it, this question, this equation. So once I will show you. You can see here once again for your understanding. So mod, you have to select 5 and then 1. So what is the value of the magnitude first? So minus 3, you have to write minus 3 here, then plus 4, so you have to write plus 4 here, then 0, so you have to write 0 here. Okay, then what we have the minus 8, so we have to write minus 8 here, then minus plus 6, so we have to write enter, so not write here enter, and then what is the next 20, so you have to enter 20. So this is what we have obtained, minus 5.7. so this is the I1. So we have to obtain the value of I1 equals to minus 5.71 4 ampere. Clear? So this is the value, and I2 is equals to, so this is minus 4.286. okay, 57, so we have round up it, so minus 4.286. so this is the value of I1 and I2, and I3 we already know, this is the minus 10 ampere. Clear? So let's see what is the value of Vx double dash. Okay, so Vx double dash is what you can see, this is 6, so I1 minus I2. So here this Vx double dash equals to 6, and it is minus 5, 7.4 minus plus, so 4.286. okay, so we have to solve it. Then 6 in bracket minus 5.714 plus 4.286, and this is what obtain minus 8.568. so Vx double dash, we obtain the value of, this is minus 8.568 volt. Okay, so this is the voltage across the 6 ohm. Okay, this is the voltage across 6 ohm when only the 10 ampere source is acting alone, only the current source. So this is the Vx double dash. Clear? And the last, by superposition theorem, step number 3. So this is the step number 3. So by superposition theorem, okay, so we have voltage across 6 ohm. Okay, so this is what voltage across 6 ohm, this is what Vx dash plus Vx double dash. Clear? So our question is what we have to find out the Vx. So Vx is, this is the voltage across the 6 ohm. Vx is what here, voltage across 6 ohm. Clear? So now you can see we have to write down the what is the value of Vx dash. So we have obtained the value of Vx, this is what 8.574. so you can see here, this is the, we have obtained 8.5764. now then you can see what we have obtained the Vx double dash. So here you can see minus 8.568. So it is what I will write here, minus 8.568. okay, and we have to simplify it. So you can see it is 8.574 minus 8.568. so here this is what, okay, this is the 0 point, this is what is, you can see that this is the value of the 6 into 10 raised to minus 3, but how we can write is, this is what, 0.00, okay, 0.006. clear? This is the value of currents, this is 0.006, and it is almost, if we can consider right here, this is the 0 volt, okay, so 0 voltage is across the Vx. So this is the our answer, clear, and this is the our final answer. So there is no voltage present across the 6 ohm, okay. So this is the theoretical question, so it can be, we can obtain the zero value on any another negative value also, but in the practical it is never, you can see some voltage is when in practical some kind of the negative value never will be obtained, okay, at least you can obtain the zero value. So this is possible only in the practical, okay. So I hope you understand this problem. I expect you will I expect your all doubts are clear here. If you have any kind of doubts, so you can drop in comments box, so we will try to solve it, okay. And it's humble request, once again I am repeating, it's my humble request, please subscribe our channel and forward these videos to your at least your 5 friends and ask them to subscribe this channel. Ask your 5 friends to subscribe this channel, okay. So because I have I have one target, this is for by end of this year I need to complete 1 lakh subscriber. So it's my humble request, without your support it is not possible. So it is humble, once again humble request, please subscribe our channel. Thank you very much.
Thank you, Naresh Joshi. Thank you, Naresh Joshi. Thank you, Naresh Joshi.